So, welcome everyone. Good morning. Thanks for being here. Today is an exciting day for us, so I really appreciate all of you coming down here. I heard traffic was bad on 101, so thanks for putting up with it. We are here today to talk about Google Chrome OS. Contrary to some of the reports out there in blogs, etc., we aren't launching the product today. There's no beta today. There are no devices today. We are a year away from announcement. Having said that, we've made tons of progress. So we want to take the opportunity today to walk you through the progress. So give you an actual demo of what we have built so far. We'll be giving a technical overview as well, explaining how we are going to go to market, as well as answer questions. But the primary reason we are here today is because we are very excited to announce the open sourcing of the project. As of today, the code will be fully open, which means Google developers will be working on the same tree as external developers. So whatever we do will be in the open. And we are really looking forward to working with the open source community to help drive this forward. So with that, let's get started. So I'm here to talk about Chrome OS, but I want to start with Chrome for a minute. The reason is Google Chrome is the foundation of everything we are doing here. So we launched Chrome about 14 months ago. In a similar audience, the comic book leaked, and we were launching Chrome. So why did we do Chrome? The goal was we had noticed that the web had evolved from simple text pages to really rich applications. So applications like Gmail, Google Maps, Yahoo Mail, Flickr, etc. And we really wanted a modern browser which was capable of handling those rich applications. So that's why we did Chrome. We really wanted to help push the web forward. So let's take a look at where we are now. So it's been a year since launch, just over a year. We recently announced we were over 30 million users. Now we are happy to announce we are over 40 million users. So the growth is very, very strong. And by users, we are referring to primary users of the browser. They use Chrome as their main browser. If we count all users of Chrome, the numbers are much higher. The three main things we focused on Chrome was speed, simplicity, and security. Mostly speed, though. We really care about speed. And Chrome is about close to 40% faster in JavaScript performance than the current version of IE, which is IE 8. So it is something which sounds abstract to most people. It's a benchmark. But where it starts manifesting itself is as you start using the next generation of web applications. For example, take Google Wave. With Google Wave, you don't need a benchmark to say Chrome is faster. All you need to do is to try Google Wave in Chrome and in IE, and most users will just notice the difference in a matter of seconds. One is fast and the other is slow. So we've really focused on speed, but JavaScript performance is just one aspect of speed. We have focused on end-to-end speed of the browser, from the time you click the icon to how you load web pages to how you interact with the browser. And most users who use Chrome write back to us, and the most common feedback we get is Chrome is fast. So we really focus on that. The next point is, over the last year, we have updated Chrome about 20 times, including several major versions. Most users don't notice. We really care about making sure software works seamlessly, and users shouldn't have to worry about maintaining software. The final point about Chrome, an area which I'm going to talk about in more detail, is we really focused on making HTML5. HTML5 is the underlying code which powers all web applications. We really want to help push the web forward, and we have done a lot of work there, and I'll share progress there as well. Next slide. So just this year alone in Chrome, there is tons of new stuff coming. So before this year gets over, we'll have 3 more announcements to make. Chrome for Mac will be ready for users to use. I use it as my primary browser now, and it's coming along very, very well. So we are very close to launch there, and it's something we are looking at the number of Macs in the room. I'm very excited by it. Chrome for Linux is also coming along very well. It's the foundation of what we are doing in Chrome OS. So that's very exciting as well. Finally, we are nearing the launch of extensions. We have taken the time to rethink how extensions should work. We want extensions to be much easier to write. So Chrome extensions are based on the same web technologies with which you write web applications, HTML and JavaScript. They are very easy to write, and as a user, they are lightweight, they don't slow down your browser, it's easy to use. And most importantly, we will keep all extensions automatically updated for users. So once you install them, you'll never have to worry about maintaining them. We're doing a lot more of interesting stuff with extensions, working with several partners. And so we'll have a lot, we'll be announcing a lot more details later this year. Next slide. I talked a minute about HTML5 and making the web more powerful. So let me explain. This is a very important part of what we are doing. because it has a lot of implications for Chrome OS. So again, our goal here is to make sure web applications function as well as desktop application. Today, conventional desktop applications have a lot of access to underlying operating system capabilities and full system resources. Web apps, in many cases, don't have access to those resources. So we are working hard, identifying every possible gap, and we are figuring out a safe way for web applications to take advantage of the same underlying operating system capabilities and system resources. Let me give you some examples. Graphics. So we are all used to running rich games on our personal computers. We want it to be possible to have the same games and other rich 3D applications within a browser. Effectively, we want web applications to get access to the GPU, which is present on most computers today. So that's one example. Let me give one more example, what we call as threads or workers. Most computers today ship with multi-core CPUs. How do we make sure web applications can run parallel threads and take advantage of the multi-core CPUs in your machine? One more example, real-time communication. We want it to be possible for any web page to have full high-quality voice and video chat built in, as an example, which means web applications need a way to communicate to your speaker, microphone, camera. One more example. You need web applications to work offline. So we are exposing a database API, effectively exposing local storage on the machine to the web application. So in each of these cases, our goal is to make sure we take web applications, give them the capabilities they need so that they can be very rich, complex applications with the full functionality of desktop applications. So we are making a lot of progress in this area. It's a huge area of push for us. And in 2010, we expect to have all these APIs and much more fully built into Chrome, as well as we are working with the other major browser vendors to make sure they evolve as part of HTML5 standards. Next slide. So while we've been focusing on building Chrome, making sure Chrome is better, and making sure the web gets better, there have been some very powerful trends happening in the industry at the same time. There are 3 trends, especially, which we are very excited about. So I want to call your attention to that. On the top left, what you're seeing is the growth of netbooks. The growth is phenomenal. To put it in perspective, this growth happened in the worst economy since the Great Depression. It's unheard of growth for the kind of time in which it happened. So netbooks are exploding. So what are netbooks? Users are responding to these because they view these as ultra-thin, ultra-light, ultra-mobile computers. In many cases, they are buying it as companion PCs to spend most of their time online, right? So we are very excited by this development. On the right-hand side, top right, the point there is hundreds of millions of users are living on the cloud. This is a trend which has been going on for a while. We notice it internally. I pretty much, by now I'm 100%. Everything of what I do is in a browser for me. And that is true for a lot of people outside. Most applications, in fact, if you take the last 5 years and think about all the interesting applications that have been written for your personal computer, I'm sure you can count with less than one hand the number of conventional desktop applications that have been written. Everything else has been a web application. So the trend is very, very clear. Every capability you want today, in the future, it's going to be written as a web application. It's the most successful platform out there. So we are very excited by that trend as well. And we're working very hard to accelerate that. The third trend on the bottom, there is tremendous innovation at a computing device level. On the one hand, you have phones. All of you are familiar with this. Phones are becoming smarter. So people call these smartphones. There are rumors of tablets. But effectively, this is phones getting on computing capabilities. They expose a rich application framework, and people are building apps for them. So they're effectively becoming computers. On the other side, laptops and then netbooks, they're becoming more like phones. There are netbooks which are selling today which have always-on connectivity. The battery times are getting better. I think in the future you will see netbooks which you can carry around with you all day and charge them in the night, just like your phone, right? And so they're becoming mobile, lighter, et cetera. So this convergence is very powerful, and we think really lends itself to a new model of computing. So looking at all these trends, the question we ask ourselves is there a better model of personal computing that we can give to our users? And we believe so, and that's what Chrome OS is. So with Google Chrome OS, I'm going to switch now and talk about Google Chrome OS. With Google Chrome OS, we again focused on three things. They'll be familiar to you by now, since Chrome is the foundation of what we are doing here. It's speed, simplicity, and security. When I say speed, we want Google Chrome OS to be blazingly fast. So from the time you press boot, we want it to be like a TV. You turn it on, you should be in the web using your application. So we want it to be very fast. In addition to just making the boot time fast, we want the end-to-end experience to be fast. Chrome itself is very fast, but Chrome on Chrome OS, because we understand the underlying operating system, as well as we are specifying components in the hardware so that we can profile Chrome and make it much faster. So Chrome on Chrome OS will be even faster than Chrome. Simplicity. This is one of the most important things we are doing with Chrome OS. In Chrome OS, every application is a web application. So let me repeat it again. Every application is a web application. There are no conventional desktop applications. So users don't have to install programs. They don't have to install software, manage updates, nothing. It's a web app. It's a link. It's a URL. So with that arises a simplicity. You know, most people, when you expose them to a new operating system, they struggle with lack of familiarity. In the case of Chrome OS, it'll be very familiar to them. It's just a browser. So it's a browser with a few modifications, which I'll show visually in a few minutes. So it's very simple to use, nothing to maintain, and the computer should just work. In addition to that, all data in Chrome OS is in the cloud. So as a user, we really want it to be easy for you to use the machine. Today, I can take any of your machines and use Gmail or Yahoo Mail. I can log into my mail. Similarly, you can take any of my machines and log into your email account. We want all of personal computing to work that way. If I lose my Chrome OS machine, I should be able to go buy a new machine, log in, within a matter of seconds, get my favorite applications, the necessary cache data back, including personalization, my background. Everything should look similar. We want it to be possible for users to share machines and feel as if the machine belongs to them. So we are working really hard to achieve that objective. The final point is security. Given what I talked about, that everything is a web application, we can fundamentally do different things with security than what's been done till now. And the reason, security is a very hard problem, right? You're never going to make a system completely secure. But we can do a whole lot better. Because in Chrome OS, users don't install binaries on the system. We understand all the code on the system. We can detect malicious processes much better. We can manage the system. If there is an issue, we can fix ourselves with a reboot. Matt Papakipos, the engineering director on Chrome OS, will actually talk about some of the most innovative things we are doing on the security front. We run completely inside the browser security model, which is very different from how traditional operating systems work today. So speed, simplicity, and security are the three main areas we are focused on. And I want to actually take the time to switch over and show a demo. We want to first start by booting the machine. So Can Liu, who's the product manager on Chrome OS, is actually going to press the button and do a cold reboot. Let's go. So we really care about how fast we can get the machine to boot. We want this to be in a matter of seconds. And as you can see, we are in the login screen, right? It takes about 7 seconds right now, and we are working very, very, very hard to make this time shorter. It takes another 3 seconds to log into your favorite application. So we're going to switch to the machine from which we have been projecting. In case you didn't realize, we've been projecting from a Chrome OS machine. So we're going to get out of the full screen mode, and we are within Chrome OS. So 2 things before I get started with the demo. First of all, hopefully this is not a surprise to you, but it looks like Chrome, right? And so internally, we joke around as saying Chrome is Chrome OS, right? And Chrome is the OS for all practical purposes. Having said that, there are many, many interesting changes in Chrome, which I'm going to walk you through to make it function like an operating system. The advantage of doing it this way is it's very familiar and intuitive to most users. Almost everyone knows how to use a browser. So we just want it to feel that way. The second thing I want to say before I walk through the UI is, at this stage of the project, we are opening up the project a year ahead of release. So we are actually iterating through the UI. I had to convince the team to stop checking in code so that we can cut a build to freeze it for the demo, right? We are checking in code as we speak. So a lot of the UI is going to change. I'm not fully sure how it will turn out, But one thing I can guarantee is it won't be exactly like what you're looking at today. Having said that, there are many, many important concepts here which we are very sure will carry over to the final product. So I'm going to focus on covering those aspects for you first. So to start with, it looks like Chrome, but on the top left-hand side, you're seeing some small tabs. We call these application tabs. So you can take any of your favorite applications. In my case, it's Gmail and Calendar, etc. But it could be Facebook, it could be Yahoo Mail, whatever users want. You can take any application and with one click pin it to be a favorite application. And once you do that, we call these application tabs. We are working very hard to make it possible for you to get to your favorite applications instantly. So once you choose something as an application tab, they always stay in place. So let's open a few tabs. As you can see, Can is opening a few tabs, but the application tabs on the top left, the 5 of them, don't move at all. So you can open, close, etc. They always stay in place. So we're working very hard to make it easy for you to access your favorite applications. In addition to this method of accessing your applications, there is on the top left-hand side, you have something what we call as the app menu. So caveat, the UI here is going to change, but the concept is we really want you to be able to discover new applications as well as access your top applications. So let's go around and start poking around the app menu. I am noticing an interesting app called Contacts. So let's try that out. Something interesting happened. Something popped from below. Internally, we call these as moles because they kind of come from underground. But we're going to call them panels externally. So panels are something which these are persistent lightweight windows, which you can have them around with you all the time. They're persistent. So for example, let's click on a few tabs. They don't move at all, right? And the panel stays. It's a persistent window. There are several interesting use cases for it. You can minimize them and make them go away, and you can bring them back. We're going to work hard to make sure we can automatically manage panels for users. So this is a chat window. So Can is chatting with David, one of the engineers on the team, and hopefully David says hi back. There you go. So buddy list and chat is a great example of how you would use a panel. Let's see what other use cases for panels are there. So let's poke around. There's Notepad. So let's click on Notepad as an example. So one more panel. The interesting thing about Chrome OS is I mentioned all data is in the cloud. So what does that mean? So Can is going to type something here, and maybe we should go to Google Docs and open his Notepad file. You can see it's right there in the cloud. All data in Chrome OS is in the cloud. So as a model, anything you put on the machine is instantly available to you from anywhere. So which is something we are very, very excited about. Let me show one more use case for panels. Let's type YouTube in the Chrome Omnibox. Recently, we launched this very cool music feature called Music One Box, by which you can type in names of songs and play it right off the Google search page. So let's click on Beautiful Day. You can see a panel popped up. And it plays right in place. It's a persistent window. You can leave it there. You can minimize it and keep working. Right? You can use this to stream music from the web. So these are interesting examples of how we expect people to use panels. Before we get caught up in the song, so let's wrap it up. So yeah, if you go to the, well, let's go poke around in the app menu once more. So what I like about netbooks is today I struggle when I go on vacations and stuff to carry my DVD player, my computer, my book reader, etc. The great thing about netbooks is these are ultralight, thin mobile devices. And once battery times get much better, you can carry them around with you as general purpose devices. So we actually expect these to be great entertainment devices. People should be able to watch videos, play music, play games, books, etc. So let's see how the experience looks like. So I'm an avid chess player, so I have this chess game which I use on my Chrome OS machine. And you can now, it's just a flash. Is it working? OK, so it's great. So Can is playing the chess game. You can see how it's very easy and visual, and you can make it full screen mode and take over the screen. So these are good examples of what we expect people to do with these machines. In fact, another good example of what you can do is read books. So for example, we are working hard on this experience, and we have ways to go. But if you look at Google Books, for example, here is Alice in Wonderland. So you can have it on your netbook in a full screen mode, and you can read conveniently. It's, these are scanned books which are available. And I can totally imagine reading it to my daughter, carrying a netbook around with me. So it's very, very compelling. So we are really interested in solving all these interesting user experiences for people. One of the things is I've spent all my time in one Chrome window. But it's very common for users to have multiple sets of windows. So we want to walk you through that experience. For example, it's the time of the year in which I'm trying to get all my gift shopping done before holidays come around, right? So I have a set of windows with Amazon, eBay, et cetera. So I can easily switch over to the other windows. And so I have Amazon and eBay. It's a completely different Chrome instance for me. And I even have YouTube. I want to take the chance to show that YouTube works and Flash works on the machine. So let's click on a video and make sure it works. So as you can see, YouTube works and Flash works. I just moved to another window. Let's go back to the original window. You can move back and forth. In fact, you can go to the overview mode, and you can see all the windows which are open on your system. The UI here is going to change a little bit, but you can imagine I can open a new Chrome window, right? And I can drag and drop a tab from one Chrome window to another Chrome window. It's very simple, very intuitive, and just works. So this is the core part of the user experience. Having said that, one of the things we realize is people are going to buy these netbooks. They're going to go home and do a lot of common things they are used to doing with computers. So we actually have a long list of all these use cases, and we are working hard to make sure it works seamlessly for users. Let me walk through a couple examples. Most people plug in their cameras, right? They may plug in a USB drive. And so what happens if you plug in a USB drive? You can imagine, this is a rough concept, but you can imagine Chrome opens a tab and shows you what's in the content of a camera or a USB drive. And you can see the files that are on the machine. It turns out in this USB drive there are Excel files. We don't have Microsoft Excel on this machine. So what happens if you click Excel file? Let's give it a shot. It turns out Microsoft Office launched a killer app for Chrome OS. They've been working very, very hard to do this. The point here is Chrome OS does not have a proprietary app framework. It's a completely open app framework. It's the web. So anybody who puts up a URL, anybody who writes an application that works on the web and in a browser is writing an application for Chrome OS. It's something we are very, very excited by. And for the record, I'm an avid Google Spreadsheets user, just a disclaimer. So there are a few other use cases people can do. Here's an interesting use case we can demonstrate. So Ken is going to take a picture. In fact, he has one of the new droids, and it has a 5-megapixel camera, so it's pretty cool. So hopefully, we're going to get a good picture out of it. And he's going to take a picture. And let's see what happens if you plug this in your Chrome OS machine. So you can see Chrome OS detects that the camera is a storage device. Now, the phone is a storage device. It can pull the picture right there. So he's clicking on the picture, and here you go. I can see Arlington squarely in the center of the picture. So it turns out there is a video on the phone as well. So let's try and see what happens if you click the video. The video plays right in place in the panel we talked about. So the point here is we really want it to be possible for all these seamless use cases, for all these use cases for users to be seamless. We just want computers to be delightful and work. So we're working very hard to make that possible. One final example like this I want to give is people run into many, many different types of files, right, when they use a computer. They need to be able to use those files. For example, let's go to one of my favorite websites. I go there pretty often. It's irs.gov. And let's poke around and click on a PDF file. Right? So what happens if you click on a PDF file? It works, it's instant, it's in the browser. Right? So that's the underlying theme of what we are trying to accomplish. Speed, simplicity, and security. So I'm going to take a step back from the demo. I'm going to turn it over to Matt Papakipos, who's the engineering director on Chrome OS. And he is going to take a few minutes to walk under the hood. But I would really encourage you to pay attention, because what we are doing is a fundamentally different computing model than what appears on the surface. Thanks.
Hi, so my name is Matt Papakipos. I run the Chrome OS engineering team. So I'm excited to tell you about some of the technology under the hood here. So the first thing to say is we're doing a big open source release today. So as Sundar mentioned, all the code is out in the open now. You can go check it out and build it. In addition, we've done a pretty unusual, interesting thing here in that we've also opened up all of our design documents. So what's the thought process behind this? Where are we going with it? What are the things we're doing next? So we're showing you not only what we've built so far, what the theory was behind it, but the things we're building next and involving the community in that whole process. So what I'll show you today is a sketch of some of those design documents. So you can see some of the technology we've already built and some of the stuff we're still working on, and encourage people to read the docs and get involved. But I'll give you a quick sketch right now. So as Sundar mentioned, speed is a big focus for us here. So we want to make it a very fast, delightful system to use. So what we're going for here is that it feels much more like a television than a computer. We want you to be able to just punch the on button, and it immediately comes on. You log in, you're on the web as quickly as possible. So let me talk about how that works. So one of the first points is all the Chrome OS hardware devices are based on solid-state storage. So what this means is no hard disks. So no disks with the moving parts with iron particles on them. So it's all entirely flash memory-based storage solutions. And that's part of why we can boot so quickly, is because we're actually just reading out of RAM rather than reading out of a spinning magnetic drive. So that makes a huge difference. So let me walk through how a conventional operating system boots. I've pictured it here. I won't show you all the details, but there's a firmware process, there's a bootloader, the kernel starts up, system services start, startup applications, browser. The user actually has to click to start the browser typically. No wonder it takes a long time. So to give you a flavor of some of the things that slow it down, when you first punch the power button, your computer still, to this day, spends time going out and probing and looking for a floppy drive. Does anyone actually have a floppy drive in their computer? But your firmware doesn't know that. Your operating system doesn't know that. So they're out there looking for it. And that's symptomatic of one of the reasons that OSs are so slow. So we've really gone in Chrome OS and cut out all of the boot steps that we possibly can. So we've eliminated working to eliminate the bootloader to merge it into the firmware portion, doing a lot of work to optimize the kernel, not start up system services we don't need. As Sundar mentioned, we don't run conventional applications, so we don't need to start up background services for them, et cetera. So we can run a lot faster. And in addition, we auto-start the browser. So as soon as you log in, we start Chrome. We bring up all your application tabs and your tabs from last session, so you're off and running. Another thing we've done on the boot front that's pretty interesting, I think, is we're working on this system that we describe in the design doc called verified boot. And the basic concept here is, exploits happen in the real world, right? There are malware breakouts on any operating system that exists. So the challenge is, once one happens, how do we figure out that it's happened? How do we correct the situation? So as Sundar mentioned, Chrome OS auto-updates itself. So we go out and make sure every day that you're running the correct version of the operating system, that you have all the security patches that we can possibly apply to you. So the essence of the verified boot process is to make sure that every time you boot, we double check that you're running what you should be running. So the basic concept is that every component of software in Chrome OS, from the firmware to the kernel, to Chrome itself, to the whole root file system, have what's called a cryptographic signature attached to them. And the basic notion is it's as if each one were a document that's signed at the bottom, with the John Hancock saying, yes, this is the right set of bits. So we're using these cryptographic signature keys to make sure that when we load the kernel off disk, we check the signature, we make sure that it is the set of bytes that it's supposed to be, and then we transition control to it. So what happens if it goes wrong? So we start to boot a system. We go through the firmware. We go through the kernel. We start Chrome, and we discover that one of the bytes is wrong, right? It fails the cryptographic signature check. So if this happens, there could be multiple reasons. It could be a malware outbreak of some kind. Chrome got hacked. It could be just a random cosmic ray error, right? Sometimes a bit flips in a memory or a hard disk. You get a random error. When that happens, we detect that it's happened. So in this case, the kernel would detect that it's the wrong version of Chrome. Something's wrong. We do the malware detection. And then we go through what we call this recovery procedure, where the system repairs itself. And so from that point, it offers the user a reboot. The user reboots. We re-download the appropriate version of Chrome, reinstall it on the hard disk, and start it up. So we repair the system automatically. And basically what this is doing is re-imaging your computer. The trick here is we've taken what used to be a very painful reimaging process, right? We've all reimaged a Mac or a Windows machine. It's incredibly painful. You lose all your data. What we've done here is made it transparent, and we do it in a way where it also saves all your cache data, saves all your system settings, so you don't lose anything in the process. And I'll talk in a bit about how that saving state works. OK, so I was talking a bit about security there. Let me talk a little bit more about security. So here I'll talk about application security. So how do we make sure that applications don't harm your machine? Because this is a primary attack vector for malware, as everyone knows. So the security model of conventional operating systems is something that was developed over 20 years ago, right? The basic application security model for conventional OS is that the applications run with your privileges, right? It's as if the application were you. Right? So if you're allowed to modify a file on the disk, the applications you run on your behalf are also allowed to modify those files on disk. And this creates a bunch of security challenges because it means that a rogue application or a hacked application could do great damage to your system or to your personal data or even leak your personal data to other parties. So it's a big deal. It also leads users to have to make some very hard decisions on a conventional operating system. When you install an application, you're taking great risk. You have to make decisions about, do I trust this application? Where did I get it? Is it safe? And these are decisions that are hard for users to make good decisions about. In Chrome OS, we've taken a very different approach. As Sundar mentioned, all of our applications, all the end user applications are web applications. And web applications, as you know, have a different security model. Their security model is apps are treated at a system level as if they're fundamentally hostile, right? And so the browser takes great pains, every web browser, to make sure that applications can't do things to your system that they shouldn't be doing. So a web application can't change files on your hard disk, right? It can't reconfigure your power settings, right? There are many things that web applications intentionally cannot do that give it a better security profile. In Chrome, we've gone to greater lengths to secure that, using a technique that we call security sandboxing. And so this is in Chrome today when you run it on Windows, for example. In Chrome OS, we've taken it to even greater length. So some of the new techniques that we're using in Chrome OS to secure these web applications, techniques like chrooting, what are called Linux namespaces, and then changes to the toolchain itself, so meaning to the compilers that we use to compile Chrome. These give us additional benefits like stack protection, things of that nature. And what the security sandbox means is that every tab that you run in Chrome OS is running completely locked down and separated from the other tabs in the system, but also from the underlying operating system. So we've protected the OS from the web applications. We've protected the web applications from each other. Let me talk a little bit about the file system. So file systems are not the most glamorous part of an operating system, but they're very important, and we've done some pretty interesting things here and are working on some more that I want to tell you about. So the first is, as I mentioned, the system is always auto-updated. We continuously auto-update the operating system, Chrome, and all the bits that are on the machine. And as we do that, there are basically what are called a few file system partitions. So on the solid-state storage drive, there are a couple different areas of the hard disk. And one of the interesting things that we've done is we've made the primary system area, what's called the root partition, read-only. And this provides a lot of protection, right? It basically means that the operating system bits on the disk itself and even the Chrome executable is in an area that's not writable, right? At the OS level, it's locked down. And this is actually quite unusual in operating systems. It sounds obvious as I say it, but most OSs today don't do this. The system is typically in a writable partition, which is fairly scary. So we've really locked it down in that regard. The other interesting thing we've done with the file system is on the user partition. So this is where user data is stored. When I set my system settings, like my Wi-Fi settings or my background theme or bookmarks, things of that nature, we've done a couple interesting things. The first one is that it's always encrypted. User data is always encrypted on a Chrome OS machine. And this provides some great benefits. One of them is safety of your data, right? Should you ever lose your machine, you now have a machine out there that has storage on it that you know has some personal data on it, you can be assured that it's encrypted, right? And this means that if some bad guy gets it, opens up your machine with a screwdriver, pulls out the drive, puts it in another computer, they'll have a very hard time reading those bits, right? As with all security, anything can be cracked, but we've made it very, very difficult. Right? They now have effectively what's a set of cryptographic random numbers. So it's going to be quite challenging to get any personal data out of it. Let's see. And then the other interesting thing about the user data partition, what really makes this a cloud device is that all the user data is synced back to the cloud at all times. So really, all we use the local user data for is as a cache, as an accelerator. So all the stuff that you set, whether it's bookmarks or backgrounds, system settings like Wi-Fi settings, are synced back to the cloud. And this has this wonderful property that if you use a Chrome OS machine for a while, all the data is getting synced back. You lose your device, you give it to somebody else, get a new one, log in. In a matter of seconds, all the data resyncs back to the machine, and it's just the way that you left it. We think that's a pretty radical, interesting notion for an operating system. So we transition back to Sundar, and we'll tell you a couple more points. Thank you.
Thanks. So I hope Matt's talk was technical, but I hope what we are trying to do here is not just another operating system. We are trying to offer a choice for users. So the model of computing we are trying to advance is pretty fundamentally different. And we really hope the community gets excited by what we are doing and we can work together. Security is not an abstract issue. It really makes a difference in the lives of people. People struggle a lot with issues with their computers. And so we really want to make it better. So I want to switch gears and talk about how we are going to go to market. This is not something we are ready to talk about in detail today. I want to give a high-level overview of what we are doing. We will be talking a lot more next year. It is important to understand how we are going to go to market here. There are a couple of interesting differences. One is we are working on the Google Chrome OS image, the software. But in addition to that, we are actually going and working with partners to specify components at the hardware level. Matt gave one example. For example, we don't support hard drives. We support only solid-state drives. We will call out the specific wireless cards we will support, as an example. The reason is we really want software to understand the underlying hardware so that we can make it much faster and more secure. So and I think that's an important part of what we are trying to do. It's important to understand. So we not only have software, we are specifying reference hardware components, and together makes a Chrome OS device, which we are working with the top OEMs to come to market. But as a consumer, for you to buy a Chrome OS, you can download Chrome OS and install it on any of your current machines. You would have to go and buy a Chrome OS device in the market. So that's very important to understand. Our target time frame is end of next year. We want to be there ahead of the holiday season with devices in the market. In terms of the hardware itself, one thing I want to highlight is while netbooks today are very popular, we do understand there are some pretty serious usability issues with some of the netbooks out there. We really care about the end-to-end user experience. So we're going to be working with our key partners very hard to make sure you see slightly larger netbooks, effectively netbooks which can accommodate a full-sized keyboard and a much more comfortable touchpad. We care about the displays. We care about the resolutions which people get on those displays. And those will all be part of the specified reference hardware components here. We really want to make sure we get compelling devices out in the marketplace. And again, this is about a year away. Let's go to the next slide. The primary reason we are here today is I'm very excited to announce as of today, the code is open. We are completely going to be developing this in the open from now on, which means Google developers and external developers work off the same tree. We will not be here today. It wouldn't be possible for us to do what we are doing today were it not for several large open source projects. We are incorporating components from many open source projects. To name a few, the Linux kernel, Ubuntu, Moblin, WebKit, etc. So thanks to all those people who have contributed to these great projects. We really hope you continue contributing to those because everything we do, we are going to be good open source citizens and commit the code back upstream so that others benefit as well. And given the new model of computing we are trying to achieve, we really hope, we are looking forward to feedback from the open source community. So if you're a web developer, we really want you to take advantage of the new HTML5 capabilities and help write better web applications. If you're an operating system developer, if you're the kind who loves to build your own operating system, you need to buy a few of the netbooks which are available today. You need that. You need a screwdriver. You need a few components. And you can get Chrome OS up and running today. So we really are looking forward to your contributions. Before I wrap up, we went through a long presentation to try and explain to you what Google Chrome and Chrome OS is. Our marketing team took a look at it and said they thought the whole thing could be done in a very different and a much simpler way. So they worked with a set of external folks to produce a 3-minute video, which I think really helps explain what Chrome OS. So we will do the video, and then I'll come back for Q&A.
So, you are on the internet using a web browser. You know, that thing with the address bar and back button and bookmarks. That thing you're in right now, up there. Yeah, that's your web browser. If you're like me, when you're on your computer, you spend something like, I don't know, 90% of your time on the internet in a browser. There's emails, chatting, you're reading news, watching videos, playing games, you're buying things, just to name a few. Which kind of makes the web browser the most important program on your computer. And if you think about it, it hasn't always been this way. You see, web browsers were first designed a long time ago with the old internet in mind. You know, back when it was slow and mainly just words with links that just send you to more words with links, back before all of these innovations. So some guys at Google asked, what if we redesigned the web browser from scratch with an eye towards the new web? You know, maps, video, and web apps that are a lot more dynamic. And so they created Chrome, a web browser that's crazy fast on today's internet. And it's sleek and more secure, but mostly it's really fast. I mean, my biggest question when I boot up my computer is how long till I get on the internet, right? I mean, if there isn't any internet, I might not even use my computer. Did you know that even the fastest computers will still take like 45 seconds to boot up? 45 seconds! You can make a sandwich in that time. So here's what's going on when your computer's booting up. There's this list of things to do, stuff I'm sure you don't care about, but it cranks through them one at a time. What you probably notice is that your programs begin loading up slowly, and if you're like me, as soon as you see your web browser icon appear, you're like double-clicking it over and over and over. Let's go, buddy, I got some emails to read. Well, all of this stuff is called your operating system. And over time, it gets rusty, and your once fresh computer gets slow. Well, Google was like, wait a second, if your operating system's a hassle and all you're really using it for is to get on your web browser, to get online, then maybe we don't need this anymore. What if when you pressed on, you were on the internet in seconds? What if your browser was your operating system? And so check this out. This means that you don't have to deal with managing programs or nagging updates or lost files or confusing settings or blue screens of doom, and there's no nagging updates. Just your browser. Which means you can still listen to music, you can watch movies, interact with friends, you're creating documents, you're playing games, you're writing your emails, you're doing all of this stuff that you were already doing on the internet. But here's the thing, none of this is stored on your computer. What? None of it, you ask? Yeah, none of it. Really nothing? Yeah, nothing is stored on your computer. Well, where is it? It's on the internet. You know, like when you access your emails from your computer and your phone, the email, it isn't stored on either device. So if everything's stored on the internet, then your phone, your computer, all of these devices are what people call stateless, which is kind of a big word, so maybe just remember this. Chrome is a totally rethought web browser, and you can download it right now on your computer. But Chrome OS is a totally rethought computer that lets you stop worrying about your computer so you could focus on the internet. Which is what most of us use our computers for nowadays, anyways.
So, thanks. So we have some time for questions. I think the way I thought there were going to be mics. So there is a mic down here and a mic down here. So if you could, given we are webcasting this, would greatly appreciate it if you can walk, or if not, I'll repeat the question. Yeah, so there's a mic down there. Thank you. And there's a mic down there as well.
Hi, my name is Christian Grant. This is an amazing innovation, and it seems to make things easier for users. There just seems to be so many questions I have. One question would be, this seems to be, I mean, what is the focus group for this type of device? I mean, I could imagine, I mean, for example, I have this Android device at the moment, and they're the developers that are developing Android apps. So one question could be, can you run Android apps on Chrome OS? But another question I have is, I was joking with Larry Ellison about now the Android devices are becoming so powerful. I mean, soon there'll be a 1 gigahertz processor and 64 gigabytes of memory in the Android device. So I could move my data center to the Android device, so that becomes the cloud. So the other question is, could Chrome, would that be like a Chrome server solution? So it's not just a client device, but actually the cloud device? I think those are some of the questions I have, but
No, thanks.
many more.
There are many interesting possibilities. I mean, we are clearly focused on first getting great netbooks out there, to be very clear. But the good thing of what you're pointing out is, I do think, even across Android, what we are doing, there are large innovations that are going on. They're all open source, and they all involve the community. And when you have open platforms like that, I think we are going to go through a paradigm shift in computing, which is what we are excited about. In terms of the other possibilities you're talking about, time will tell. So, next question.
Hi, Tom Krazit with CNET. If you're specifying hardware components, it would sound like you likely have a decent idea of what these things are going to cost. Can you give us some idea of what we can expect a Chrome OS netbook to cost next year?
So, no, you will hear those messaging from our partners as they come up with devices. We expect to have devices in the price ranges people are used to today. Having said that, it's tough to predict the hardware curve a year ahead of time. So we are focused on getting netbooks out there which are very easy to use, and so you will see larger netbooks than what you're seeing today. So we're working hard to accommodate a full-size keyboard, et cetera, as I just mentioned. But in terms of the price point, our partners will announce it next year.
Do you have a price target that you are specifying for your partners?
Sorry, what's the question?
Do you have a price target that you are asking your partners to hit?
No, we are not.
What's that notebook right there? The one you're running on?
I think that's an off-the-shelf EPC. So,
What model?
I don't know.
It's actually, we'll have all that information.
Sorry, let's
up on the
repeat.
site.
Since people are on the webcast, my cast, what's the netbook which is
Sure.
which was on the demo and we just responded. So let's go to, we'll keep swapping sites.
Couple questions. First of all, are you planning on, for the APIs to be supporting the W3C work on Device API Working Group, supporting those standards? And second question, as I understand it, you're going to be specifying down to the component level what the device can use. If you're a manufacturer and would like to be included in that, is there a process to apply to be considered?
Let me answer the second part of the question first, and Matt will answer the API question. So in terms of if you go to, we have a lot of documentation on our website, and we've been reaching out to all the top partners by now. So we are reaching out pretty aggressively and trying to work with people. So for most partners, the information has already been trickling down. I mean, it's been going both ways between the two companies. We will also have plenty of documentation. For developers who want to try this out, if you come to our website, we have a page by which manufacturers can come and say which of their devices can support Chrome OS based on the components we have specified and what changes you need to make to those devices to run them today. But we are working very closely with partners.
Sure. To answer the standards part, yeah, we're working very closely with the W3C, the WhatWG, the Kronos group that owns the OpenGL and WebGL standards to standardize as much of this stuff as we can. The device API is one you ask about. I'm not as familiar with the details. We're definitely looking at that, and I was looking at some of the stuff the other day. It's still in the fairly early phases, but we're tracking it closely. And with web standards, it takes a while for this stuff to get finalized, and so many of those are still evolving, and we're tracking it and involved very closely. But in general, we want to see all this get standardized and supported across multiple browsers running on multiple operating systems.
Jean-Baptiste Su with the French News Agency. Will you think about having an application store, like let's say like a market for Android? And what about a driver certification? Is Google going to certify all the drivers that OEMs will have to develop for, let's say, video cameras or cameras? Last question is, what about maybe editing applications? So if I want to edit photos or videos, I can. It seems I cannot do it with Chrome OS.
Okay, so there are 3 questions there. So let me remember and go through them. The first question is, will we have an application store? So we'll have a lot more details to announce in this area. I showed some initial concepts of how people can discover applications. You saw me play a chess game. We really care. The web has great applications. I see every other app platform count the number of applications. The reason they can count is it's countable. In the web, there are hundreds of millions of applications. So our job is to make sure people can discover those applications. So we'll be working hard at solving the problem. Your second question was
driver
I
certification.
can take that. So on testing of drivers and selection of hardware components, we're working closely with hardware partners on that stuff, and we definitely want to make sure that the systems are built with based off our reference designs that Sundar mentioned, with very high quality components, with open source drivers wherever possible. And we definitely have a testing plan that we're working on to make sure that it all works at the end of the day. The drivers are of the highest possible quality. Absolutely.
the third question. I'm sure the question will come up in different forms. So the question is, there are applications today which are not available on the web. And you mentioned a few examples. The short answer is, first of all, we are really focused as the use case for this device. Most people who buy this device next year, we expect them to have another machine at home, right? We are trying to deliver a device, a companion device. It may be your primary device in terms of the amount of time you spend, right? But the goal of this device, for it to be a delightful experience for you to be on the web. So that's the scenario we are focusing on. There are a few use cases where it's challenging. Even in those areas, there are actually alternatives on the web than people realize today, right? So we will be doing a good job of surfacing those applications which can solve those problems. There will be some things which this will not be able to do. If you're planning to spend your entire day, if you're a lawyer, editing contracts back and forth, this is not the right machine for you, not what we will come out with next year. So, thank you. Question?
I'm wondering about codec support, generally a problem for desktop OSs, especially from an open source point of view, and
Sure.
also native client support. Does everything that works in Chrome work in Chrome OS?
Yes. So I'll take the second part first. So certainly everything that works in Chrome works in Chrome OS, and that includes codecs. So the codecs that we've done with HTML5 video codec and audio codec certainly will make sure they work in Chrome OS, and we're working to add support for more and more codecs. We also, as you saw, we run Flash today, and we run the Flash codecs, and are very committed to that. We're also doing a lot of work with codec hardware acceleration. Right? It's not enough to just run it with a traditional decoder. We're also working to hardware accelerate those as much as possible wherever possible.
And then Chrome native client, are those hardware accelerated that have been built into the whole hardware experience as well?
Yes, so all the stuff that's available in Chrome will come in Chrome OS as well, and we do think native client is an important part of this story.
Yes, and to go back to the previous question, we didn't talk about it today. In addition to the HTML5 capabilities you heard about, we are investing a lot in additional technologies like native client, which will make it really possible for some of the most performance-intensive desktop applications to be written as web applications.
Sure.
So we are working on that. And you asked, will all that is in Chrome be in Chrome OS? That is true. But more importantly, a lot of what you see in Chrome OS will make its way in Chrome. So, and I think that's an important part to realize. On day one, when we launch this, a lot of the capabilities, and if you're an app developer, what we expose will already have well over 50 million users, right? Because every Chrome user will be able to see the applications menu, etc. So I think that's very, very important to understand.
Do you support Silverlight?
So the question from the middle was, will we support Silverlight? So Chrome OS today, users can install binaries on the system. So in the case of certain select plugins, we are working hard to integrate it closely. So we will have a lot more to announce on how we plan to provide for plugins in the future.
But you're working with Microsoft to support Silverlight.
Sorry, I don't have anything to comment on that question right now. Question there?
Yeah, my question was actually about plugins. You've already said multiple browsers will be able to run. So does the browser vendor have to go through you to get on the machine, or how would that work? And then other parties that supply plugins to those browsers, how do they get on the machine?
Sorry, I think Google Chrome OS, Chrome is the OS, right? So when you say other browsers run, so what we have tried hard to do is end-to-end Google Chrome OS is open source. It's free, open, and redistributable. So if another browser vendor or anyone else out there is interested in making a similar operating system with their browser, we want it to be possible. So we are working hard to make sure the code is available for them to do it. But to swap, so that's the way I would answer that question.
Okay, but didn't you say before multiple browsers will be able to run? Isn't that what you said?
I don't recall either of us ever saying that.
So there has to be a certification process by Google first before any other browser will run.
No. So just so that you understand, in Google Chrome OS, Chrome is the operating system. So there is no certification process for another browser to run. The entire code is open source, so someone can take it, put out a version of it based on another browser. So
it's very similar to how things work with Google Chrome, right? So we build and ship and auto-update Google Chrome, and millions of users use that. There's also the Chromium open source project, and many people build their own variants of Chrome called Chromium, and they change it in any number of different ways, and we expect and encourage that, and Chrome OS is exactly the same way. We expect people will do many interesting things with it.
Let's take the next question.
Do you envision the device exclusive or the system exclusively running on netbooks, or do you see a variety of devices using this? And then the the second question is, are you able to speak to any of the hardware partners that you have?
So today is the announcement of the open source project. We will be announcing details around hardware middle of next year, since the devices are going to be in the market by end of next year. And the first part of your question was?
So you've spoken almost exclusively about netbooks. Do you see it running on laptops, on desktops, on a variety of devices?
So the question is, we are initially fully focused on, it's a scope issue for us. We want to make sure we deliver very compelling devices. So we are initially focused on what I would call netbook-like form factors. So essentially clamshell with a display, real keyboard, and a touchpad, right? That's what we are focused on. In terms of how we are designing the system, we aren't constraining it. So in the future, we want this to be able to run on laptops, desktops, etc. But we are not focused on that for 2010.
Just to make it easier for our readers, how big is the program, and how does that compare from the conventional software, operating system? So the file size.
So,
it's going to change over time.
Yeah, so since it's an open source project, we have a lot in the code right now to help with debugging, etc. So I think you will see that develop and change over time. The code is out there in the open for people to see. But we are working very, very, very hard to have a very, very simplified code stack. And that'll be clear for developers who can see it out in the open. Thanks.
I'm Harry McCracken with Technologizer. Can you speak to whether there's any level of offline access in terms of whether Gears is part of this? And what happens when I'm on a plane and I don't have Wi-Fi, or I don't feel like paying $10 for Wi-Fi?
So the question is, how do we provide for offline access? So first of all, there are a few things we are thinking about. This device is primarily intended for use with connectivity. Wi-Fi is the use case we have in mind, and we are designing it because it's primarily for you to spend time online. Having said that, I showed experiences by which you can plug in and play media, right? So you can cache media locally, and you can watch videos, read books, listen to music, etc., play games. So that's something you'll be able to do while offline. In addition to that, as part of the HTML5 capabilities, we are exposing offline capabilities with access to local storage. So any application which takes advantage of the HTML5 offline capability and implements on top of it will work while you're not connected. So those are the things that will happen.
Are you specifying wide area wireless networking in this notebook?
Want to take that? So we're focused on 802.11n, which is the next generation 802.11 standard. So that's the mainstream wireless technology that's in use primarily today. So that's our primary focus.
So hold on. Since we're on a webcast, I would really appreciate it if you guys use the mic. Otherwise, people can't hear the question. Thank you. Sure, but there are people standing in line too. Thank you. So next question, please.
I'm wondering about virtualization. Can it be run in a virtual machine now? Can people try it out today?
Today, you can build the source code and run it in a virtual machine, and certainly we do that for development. That's a very convenient way to do development. So the focus today of the open source release is to get developers working with the code, being able to compile it, being able to debug it, and a virtual machine is a great way to do that.
Thanks.
Thank you.
Hi, are you working with partners? I know that Adobe, I believe they have a solution, a web-based Photoshop solution. Are you working with other partners and maybe developers? But you said it's probably not a development machine. But let's say at one point, as netbooks become more powerful, maybe developers using Eclipse. I don't know if there's a web-based Eclipse version, but are you working with partners on web enabling some of the applications? And the other question is, I think one of the success factors for Android is the marketplace. There are many reasons why it's so successful. And then I was just wondering if Android apps would run on Chrome, but they're not web apps, so maybe what are your comments on that?
So in terms of advancing more web applications to work, so independent of Chrome OS, this is a major part of our focus. Writing Chrome itself, one of the things we tried to do was to really push web applications forward. HTML5, native client, so there is a lot of work we are doing. So things like Photoshop on the web, we are very excited by it. And the way we approach it is we want to make sure the browser works and has the capabilities for those things to happen. The second part of your question is, will Android apps run on Chrome OS? The answer is, since every application in Chrome OS is a web application, Android apps as written today will not run on Chrome OS. Mike?
Just to follow up on that, actually, I was going to ask a similar question, but Steve Jobs said the same thing when he first launched the iPhone. Like, you know, you can launch any app on this you want as long as it works in the browser, and you know, that's not going to, you're going to get an incredible amount of pressure very quickly starting right now to have Android-like apps working on this. Are you saying flat out there will never be, or at least there's no plans right now for any kind of third-party app system for people to get their apps onto their apps onto these machines?
So two things. We are saying currently our current plan is to only support web apps. So third-party apps will work as long as it's a web application. I would call on the form factors like netbooks.
That's exactly what Steve Jobs said when they launched the iPhone.
Let me point out a couple things.
A year, so.
Yeah, but in the iPhone, if you looked at when they launched the development framework, they did have the main applications on the iPhone written as native applications, right? And so in Chrome OS, even the apps we are writing will all be web applications. Just to see, the browser works very well on bigger form factors. And in phones, a lot of times you see these applications being written as native applications because the web has challenges. We are working hard, our mobile team is working very hard to push the paradigm there, but I think it is different on larger form factors. The web works very, very well. Next question.
Hi, yeah, a few moments ago you said that you thought native client would be an important part of the Chrome OS experience. That would seem to imply that you have an Intel processor. My question is whether you can still expect to see Chrome OS running on netbooks based on the ARM architecture, and if so, can we expect equivalent functionality on both platforms?
So, you know, our goal with Chrome OS is to run it as a very open project, and we'll be working with a full variety of partners, including on the chipset side. So, you know, Chrome OS will function both on x86 and ARM. And native client, you know, it works on x86 today, but there is work underway to make it work on ARM as well.
But that would, I mean, there would be different code delivered to a device running a different processor in that case. Do you have any thoughts on?
I can take that. I mean, we'll make sure that, I don't want to go into all the technical details today, but we'll make sure that there's a way that you can run native client-based applications that run equivalently on x86 and ARM.
Thanks.
And there's a lot of work going on in that today. You'll see more about it soon.
Sorry.
Yeah, two questions. The first is, when you first announced Chrome OS, you talked about it running on much more powerful machines beyond just netbooks. What kind of a time frame do you think that will happen on? And second, is there a direct business model for Chrome OS, or is this just the latest incarnation of getting people to be more active on the web? For example, will you be offering some vehicle for advertising directly in the browser?
So your first question is, so all we are focused right now, you know, is for 2010 getting devices. It's very hard to build an operating system and ship in a year, which is what we are trying to do. And so that's what we are focused on. In terms of what is the business model around Chrome, we are working with partners. All I can say right now is Chrome OS is fully free. It's free and open source. And we really, we are fortunate that as the web gets better and people use the web more, it benefits us as a company. So that's essentially the crux of how we think about it.
So will there be any specific new real estate devoted to advertisements, or will it be just the existing ones we see in Gmail and Google search results?
There are no plans. Every application in Chrome is a web application. It's the same application you will get on any other browser, in any other computer.
Hi, Carsten Lem, German news magazine Stern. Your demo made me wonder, in terms of browser functionality, what is it that Chrome does that a regular alternate browser logged into all these cloud services cannot do? Because when you speak of floating palettes, whatever, to me it looked like just another pop-up window and things I could maybe do with Firefox or any other browser.
Sorry, your question again, I fully didn't understand it.
Oh, sorry. So the browser functionality of Chrome, what you demoed, is that anything I cannot do with the current browser that is logged into all of these web services, cloud services?
If your question, look, Chrome, we take a standards-based approach to Chrome. So most of what we show here is available in other browsers. Having said that, there are a lot of new user concepts which we are exposing today, which are not available in other browsers today.
For example?
Application tabs, panels. I mean, these are things which we have done which are not available, the OOV mode. But more importantly, our goal isn't to say what we are trying to offer is a fundamentally different model of computing, a model in which from a user standpoint, you aren't installing, managing software, you aren't managing data. It's very fast, very simple, and very secure. So I think as a model of computing, what we are attempting to do is very, very different.
And does that affect me also on non-Google Chrome netbooks on a regular machine where I would just install Chrome? Do I also reap the benefits of your approach?
Not everything. For example, in Chrome OS, Chrome is tuned to run on the underlying operating system and hardware, right? So those benefits won't carry over. But some of the user experience benefits we provide in Chrome OS within Chrome will carry over to Chrome on other platforms. So it's on a case-by-case basis.
And I can give a couple examples there. So things that we can't do on a conventional operating system that we can in Chrome OS are things like the verified boot that I mentioned, so the malware prevention, the fast boot stuff. We can't make your existing operating system boot faster. And then the file system stuff. So I mentioned we did a lot of really interesting security things with the file system that are underway. I can't do that to a conventional operating system either.
Okay. Great.
Hi, Glenn Chapman, AFP. Thanks for taking the time to brief us today. The broader concern that people expressed over and again about the cloud is how are you going to get people past why should they trust the reliability? You know, the internet's going to crash, Gmail goes down, all of a sudden I'm done for 2 hours. And then what are you going to do to assure people about the security of their data that once they give Google servers all their personal information, that it can be trusted there?
So answer your first question is, our point here is pretty simple. If your cloud is down, it affects on any computer you're on, because most people are what they are doing. You're using webmail, whether from your other machine or on Chrome OS, right? And so that is important to understand. I think when people talk about reliability of cloud services, what I would like to see is a comparison of the reliability of the cloud versus what they actually have today. And I think I think that's the right comparison to make. I think the cloud will compare very, very favorably in those scenarios as well. The third is in terms of trust and so on. I think it's really important that users have choice. At a high level, we are fully open, so everything we do there is transparent to at least developers who can educate users about what's happening. The second is, we let users are always in control. You can decide what to do. You can decide whether to buy a machine. Like today, you use webmail. When you use webmail, your email is stored in the cloud, but it's a decision users make. So that's the right way to think about it. So.
Hi, Phil Keys of Nikkei Electronics again. Couple questions on, first of all, on the data syncing of actually the data that's cached by Google Chrome OS. Is that also open, or is Google going to be the only one that will actually host that data in the cloud? Is the first question. And the second question is regarding the signature process. Is that something that Google will be in charge of, and will there be a charge for that?
Yeah, I can talk about the signature stuff. So the signature stuff is based on open algorithms that have been out there for a while, and our plan is to open source that whole thing as well. So, and we want that sort of review by the security community. We want them to poke at it and help us assure that it is secure. It is something where we're using it to secure our auto update system. So we would sign the binaries at Google for the Chrome OS, executables themselves and distribute them. So we'd sign them here. There isn't any signing that we're contemplating for the web applications users would run on the machine, right? So you don't need to run a signed version of Facebook or anything like that. Certainly we wouldn't want to do that.
I want to take a chance. Sergey has dropped by, so let's invite him for the Q&A as well. Let me grab a chair.
Hi, everyone. I wasn't expecting to participate in the Q&A, but now that I called up, I guess I'm in the hot seat.
So, next question.
Hi, my name is Christian Grant. I know that one of the, it runs JavaScript really well, the new Chrome OS. And I was wondering, or some browsers nowadays, they support Java. And if your Chrome OS at one point in the future would support, let's say, Java in one way, if there's running let's say, a Dalvik virtual machine, then in principle you could run Android apps, right, on the Chrome OS. Do you see that totally unimpossible? I guess it's more a suggestion, or would it make sense at some point in the future?
So, I mean, it's a good suggestion. Technically, there's nothing limiting a lot of what you're talking about. We are focused on creating the use case by which everything is a web application, so that's what we are focused on today. In addition to the HTML, JavaScript, native client is an area we have talked about, but hopefully there are more interesting things we can do in the future. So,
John Stokes. So Dell has a laptop that's a full-size laptop, but then it has a small separate subsystem with an ARM processor and a chunk of flash in it, so that you can boot to this instant on OS. This is kind of popular to make these Linux-based instant on OSs that are complementary to like a full Windows install, stuff like this. Do you guys have any plans to be like a second OS, like an instant boot OS, on a more full-featured laptop with magnetic media?
No, we're very focused on the Chrome OS thing. So what, the way I think about it is we're trying to make the core base operating system just boot wicked fast, right? Get you on the web as quickly as possible. So we're not spending a lot of effort on things like dual boot or multiple types of processors in the same system. We're really focused on making a lean and mean netbook that runs the web really well.
Thanks.
And just Ben Parmashable, so no drivers, that type of thing. So I guess especially I just want to dig deeper in. So this thing's not going to be able to run printers, or like how this deeper with using devices, because we have so many different devices that we use, everything from flip cameras to our printers. How is it going to handle it, and how is it going to handle it in the future?
So we plan, all standard keyboard, mice, and anything which identifies itself as a storage device, like most cameras do, etc., will work. You saw in the demo, we plugged in a Droid phone, and it worked. In terms of printing, we are taking an innovative approach to printing. We will have a lot more to share about it next year. Yes, Chrome OS will print, and we are working to make that possible.
Thanks.
So, any other questions? Great. Oh.
So about it, when you introduced Chrome, I think a lot of it was putting a stake in the ground and inviting the community to come and talk to you and become involved with your upstream open source providers. I see this as I see Chrome OS as another opportunity to do that. You're very early on. Can you talk a little bit about how you hope, by releasing Chrome OS today, the community of hardware vendors, just as you'd have to with ARM processors and such, and all the things that have happened in Android and Chrome, how do you hope this community blooms out of Chrome OS and comes together to kind of move it forward if you look towards release in a year?
Yeah, great question. I mean, that's why we're here today, is we're really excited to get the open source development community involved in this. And as you say, there's two sides of that. One is independent open source developers out there who just want to help us build a great operating system. We're delighted to get them involved, and also excited to see some of the technology that we make go out and help other projects. So we're very serious about upstreaming what we do and then downstreaming to benefit from other things the community's making. On the hardware processor component vendor side, absolutely. This makes it very much easier for us to work with hardware vendors and processor vendors, and lets them help get stuff running on their systems, and we're very excited about that. So those are some of the main reasons we're here today, is to get this code out there in the open and start collaborating.
Sergey, there was some discussion on an earlier slide about real-time notifications on every page. Do you have any comments on what that means?
Oh, now you're grilling me because I wasn't here. The question was, what about real-time notifications on every page? I think we definitely need support for real-time notifications in the browser, and in particular in Chrome OS. I mean, just even today, you guys might use Gmail chat in your Gmail, but if your browser is off, then you don't get alerted. Somebody can't pop up a little widget, and I don't think that's a good reason to not have chat be a web app. It's just capability that's today missing from the browser. And hopefully we can introduce that into the browser as well as Chrome OS.
There is a W3C standard that's being discussed in the working groups right now called the Notification API, and we have an implementation of that we're working on in Chrome, and it'll be a big part of Chrome OS.
Will that interact with what you're doing with Wave?
I imagine that Wave would be a customer of that for sure.
Exactly. Great.
Carsten, Star Magazine again, since we have Sergey now. Sorry. What is Chrome's strategic position for Google? There's often, a war of the clouds being declared, and Google going head-to-head with Microsoft. So now you're even making your own laptop, so to speak.
Well, the operating system for it. We really, call us dumb businessmen, but we really focus on user needs rather than, think about strategies relative to other companies and whatnot. And I think there's a real user need to be able to use computers easily. These netbooks are now, $300 or $400, really easy to buy one. You could buy 5 to put around your house. But if you did it today, there's no way you could manage them, right? I mean, the overhead of managing the software on all of them would be way too high. We believe that the web platform is a much simpler way, where the machines are essentially kind of stateless, more cache-like, and we think can still be performant, and yet much easier and simpler for individuals to use. So I think since that's a very important need in the market right now, that's what we're trying to fill.
With that, thank you all for coming. Really appreciate your time and look forward to talking more about this. Thanks.